Hello, we had a question about 61 and 63 on homework on page 292. Okay, those are a couple of definite integrals. And 61 looks like this. From 1 up to 3 of 1 over t dt. Now previously, we would have done this on our calculator, right? So I'm going to go ahead, get out my calculator, math, doing it right here, okay? And we're just typing it in like we do here. So this is 1, this is 3, and this is 1 divided by x I'm going to do here, and then x, and boom. And according to Mr. Calculator, I don't know if you can squint and see that, that says 1.0986, okay? 1.0986. Now, where did that come from? And also, previously, we could have used some sort of approximating process with triangles. But what's the kind of the analytical antiderivative method for this? Well, the idea of this is simply this. Okay, just to kind of summarize here. We've got that integral, like the one here, where f of t is 1 over t, right? And there's some other function, capital F of t, whose derivative is equal to f of t. Then our fun theorem of calculus simply says that that integral right there is equal to f of b minus f of a. In other words, this picture here. Right? That's the number that we want, that area, which is f of t, right? Okay? Because the area above the curve is the derivative of the area under the curve. It's the rate of change of it, right? Okay? Kind of where we started out this whole integral business. Okay? And so we subtract f of b is, let me get a couple different colors here. Sorry about the arm. Okay, so f of b would be, let's say, that area back to 0, and f of a to the right of it, to the, starting at 0, and then f of a is 0 up to a, and so if we subtract the two, what's left over is the area under the curve, the overlapping area, right? So, here's what we do. We simply take the antiderivative of this. Now, how do we do that? Well, we reflect on the fact that we had this rule here, that when we had the derivative d dt of ln t way back when, its derivative was 1 over t, right? The derivative of ln was 1 over t, oopsie, dt, okay? So what we're doing is we're working this backwards. So this antiderivative here is just equal to ln t. So is going to be equal to ln 3 minus ln 1. Okay? So what does Mr. Calculator say that is? There it is, ln 3. Hopefully you can, I'll zoom in temporarily so you can see that. ln 3 minus ln 1. Boom. Same number we just had that Mr. Calculator told us, okay? So that's how that goes, okay? Back up. Now, all of these problems in here, That's equal to 1.0986, rounded off. Okay, there it is. Now 63 is, okay, so that's 0 to 2 of 3 e to the x dx. Well, first, what we do is we take that constant and we move it outside. So that's going to be one of our integral characteristics. So that's going to be e to the x dx, right? And we remember that the derivative of e to the x was equal to e to the x dx, right? So that antiderivative is equal to just e to the x. So it's going to be 3 times e to the 2 minus e to the 0. Okay? So, Mr. Calculator says that 3 times, doing it right here, 3 times e to the 2 minus e to the 0, oopsie, minus e to the 0. Careful about my typing here. And that's 19.167. That's what it is. All right, very good. So those are those two. I'm going to post these on Canvas. Bye.